and then I'm going to try to present to your screens, and hopefully we'll be able to do that. Because let's see, are you guys seeing my drawing, a little drafting table on your monitors? Good. All right. So I'm going to show you how designers sketch, and like I said, this is something you can learn to do and get good at, but you will have to practice. It's kind of like the freehand lettering. So I'm going to move over here to where my drafting table is, and so I've got my little portable drafting table. I'm going to show you my triangle here. The triangle that I'm using here, this is a 30-degree triangle and a 60-degree corner down here and a 90-degree corner up here. We call this the 30, 60, 90-degree triangle. And I'm not going to depend on this to draw. I don't want you guys to think that when you draw isometrically you have to have a triangle, but I want to make a point with this triangle. So here's what I'm going to do. I'm going to flip this guy around here, and I'm going to draw just a line. And the line that I'm drawing here is at a 30-degree angle. And that's 30 degrees if I measure it to the horizon, like that. Okay. And I'm going to flip the triangle over, and I'm going to draw another 30-degree line. And I'm going to show you also, put a little 30-degree on that. And so in isometric drawing, you have two axes, and if the planes that you're drawing are normal, if they're not inclined, the angle of the lines that you're going to draw in your isometric drawing are going to be at 30 degrees. Any vertical lines you draw are going to go straight up like that. So right there you have the corner of an isometric sketch or an isometric drawing. Now, what I'm going to do, I'm not going to rely on this guy. I'm going to switch over, and I'm just going to sketch freehand now, because the important thing is that you get a concept in your mind of what 30 degrees is, and that you sketch along a 30-degree angle, and you sketch parallel to like in this case, it's a perfectly 30-degree right down here. But you know, when you're sketching out there in the real world and you're doing this real quickly, you're not going to be exactly at 30 degrees, but you want to be close to 30 degrees. And you want this line here to be vertical. All right. Now, over here, I'm going to take this line, and I'm going to run it parallel to where that one was. And I'm going to come out a little ways. And then I'm going to run a line parallel. I'm going to run this guy in at 30. And where they meet, I'm going to stop. And so I've created a plane there. So now you're starting to see that this thing is starting to look a little three-dimensional. So I'm going to go a vertical line here and a vertical line here. And I'm going to take this guy at 30 degrees. I'm going to bring this straight up like that. And then I would bring this across, and I would bring this back, and kind of have to draw this up near the top of my page because there's several things I'm going to draw on here. But there's sort of an example of an isometric drawing. And so vertical lines run vertically, and horizontal lines run at 30 degrees. All right. And sometimes, though, you're going to have holes added to those drawings. Okay, so there's a couple of holes drilled down through my isometric drawing. If I had holes on this plane over here, they would run at this angle, like right there. And you can see that the angle of the holes that are on these planes up here and the holes over here on this side angle are running at a different angle. And over here and over here you have different angles as well. Okay, so those are ellipses that represent holes, and those are oriented correctly in this drawing here. And I'm going to explain how you do that, how you know where to put these. Okay, so the first holes that I drew were these guys up here, and I'm going to put some marks on this plane right here so you can kind of highlight that plane. This plane right here is called a horizontal plane. All right, because it's parallel to the ground or the horizon, right? We refer to that as a horizontal plane. Now, that's the actual correct word for it, or terminology for it. AutoCAD calls this an isotop plane, like that. And we'll get into that later, but isotop was not a word that existed until AutoCAD came along, and they started working on figuring out how they were going to do isometric drawings, and I think that they didn't know the concept of horizontal plane, so they called it isotops. So that's what you'll be seeing today when we start working with AutoCAD. Okay, so that's a horizontal plane, and so whenever you have a horizontal plane and you have a hole in it, the major axis of that horizontal plane is on a 0 degree line, like that right there. It's just a horizontal line. Now, so let's talk about what a major axis is. I'm going to draw an ellipse like this guy here, and you could draw lines through this ellipse at angles and all that kind of stuff, but the longest line that you could draw through that ellipse is this line right there, okay, from this point to that point right there. And what that represents, that line right there, is what we call the major axis. And we actually align these ellipses along their major axes. And so even in AutoCAD, you will have to flip the angle of your ellipses to match what plane they're on. So this is an important thing. And actually the way that you flip that, AutoCAD calls that toggling. I'm going to show you guys. You're going to press F5, and that's how you will toggle. Now, if that doesn't work for you, if F5 doesn't toggle it, and so when I say that, I could be speaking with anybody here that's using a Mac or a Mac version of the program. Sometimes the Mac doesn't work when you do F5, and so what you are going to probably try in that case is Control E instead of F5. Control E actually should work even with a PC, but F5 is the function key that we use to change these angles. All right, so again, this long line we could run right here is called the major axis. The major axis on holes that are on horizontal planes runs at 0 degrees. So this would be 0 degrees right there, okay? So let's look at these holes we have over here on this plane. This plane that we have here, let me draw a few lines on it to kind of identify the way it's running. Okay, you see this plane right here? This is called a vertical plane because it's perpendicular to the ground. It's running up and down, okay? And and because this one goes off toward our right, like that, we call this a right vertical plane. All right. Now, AutoCAD doesn't call it that because it doesn't know anything about drafting really, and so what the designers over there, or the software programmers at AutoCAD, called this is an iso right plane. So there's two things going on here. There's terminology that AutoCAD made up, and then there's the terminology that students of technical drawing actually use to describe these planes. And since, you know, I want you guys to actually be students of this, I'm trying to show you, you know, all the correct terminology and everything here. Okay, so let's look over here on this plane. Now this plane is going from our origin point right here. It's moving back to the left. And so this is called a left vertical plane. And AutoCAD refers this as ISO left. And so now I'm going to get to, you know, the point I was going to make. So you've got a left vertical plane, you have a right vertical plane, and then you can see these two holes that I sketched in there on this right vertical plane. The major axis for those two holes right there on a right vertical plane runs at 60 degrees relative to the horizon. Okay, So here's what you need to know. Your lines are running at 30 degrees, but when you orient the ellipses, they're going to be oriented at 60 degrees. If you don't put them at 60 degrees, they're not going to look right. And so they also will point up and to the right like that at 60 degree angles, right? So whenever you have an isometric a hole on a right vertical plane, it's going to be aligned like this. Now look over here at these guys. These are holes that are on a left vertical plane. They're also going to be ellipses, and their major axis would lie along that line right there. And the angle for those is 60 degrees on that direction. Okay, just like I said, your lines are at 30, your major axes are at 60. Okay, this is what, like I said, if you want to be a designer, I think you've got to get this concept into your head, and it takes a little while to get that. And so when I was trying to get this into my head, I started making the one sketch over and over. And I would sketch it all freehand, and I would do it when I was sitting in meetings or just bored or whatever. I would just draw cubes with holes in them. And so I'll sketch one for you right now. So I would start by drawing a 30 degree line and a 30 degree line and a parallel 30 degree, and that would be the top of my cube. From that corner I would come straight down, and I would come straight down the same length here, and I would draw another 30. And so this is 30 degrees and this is 30 degrees. They're parallel to each other. My vertical lines are parallel. And then I would come over here and draw a line straight down. And then I would draw a line again that's parallel to this line, and there would be my cube. All right, so I would practice this over and over, trying to get my, my 30 degree down and my 30 degrees in this direction, like that. And then what I would do is I would add holes to it. So I would go up here to this top view, and I want to show you, if you were to draw a line from this corner across like that, your major axis, if this is a cube, would lie on that line right there. If you've got a cube here, if you connect these two corners there, you've got a 60 degree angle, and if you connect these corners over here, you have a 60. And so if you draw your ellipse along those, you'll have your ellipses oriented correctly. And so this is the good practice kind of thing to just start making that a part of your day. If you've ever got a pencil or a pen in your hand, sketch. And then what I would recommend doing, not only sketching, I would recommend lettering, practicing your lettering while you're at it. And remember I said with your lettering, you want to make your letters wide, and you want to use all caps and so on like that. And so when you put all of this together, what starts to happen is you start to look like a designer. You're sketching the way designers sketch, right? And you won't look like an idiot out there in an office when you start sketching and it looks like you sketch and letter like you did in the second grade. All right. So it's something that you ought to practice, and I'm telling you that here in 1405. And then you're going to go take all these other CAD classes from ACC, and you're not going to have to sketch a lot in most of those classes because they're going to be focusing on the CAD. And so if you don't practice this, you're going to get out there into an office, and all of a sudden everybody around you is sketching and lettering as they design and all, and you won't look like you know what you're doing. So it's something that it's definitely worth working on. All right, now I want to show you some other things about what I sketched here. Once you understand the orientation of those ellipses like that, here's what you can do. If you need a cylinder and it's an upright cylinder, you just sketch one of those ellipses that would be on a horizontal surface like that, and then you bring it straight down on the sides, and you just repeat that ellipse. Now it would be hidden in the background back there, but here you have like a vertical cylinder. Now I'm going to sketch one. I'm going to show you how actually the center lines ought to go on that. The major axis is not a center line for this ellipse. The center lines are on 30-degree angles and would look something like that right there. And then because this is a cylinder, it probably has a center axis, and that center axis would run right down through the middle like that and come out of the bottom. And look at that, all of a sudden you look like you're a designer, you know. So if I need a vertical cylinder, I know to orient it at 0 degrees. I'm going to put this up here a little higher. If I need a horizontal cylinder, one lying on its side, I draw that 60-degree ellipse. My lines here go at 30, and then I repeat another one of those 60-degree ellipses over here. Now my center lines on this one are going to be vertical like that, and then also come at 30 degrees, and then I'm going to run a 30-degree center axis down through the middle. And if my cylinder needs to be going this direction, this is at 60 degrees. My lines here on the side, I'm going to run at 30. And then I would just copy this ellipse back here. Now the reason I'm saying that is, this is how you would do it in AutoCAD. You would place your first ellipse, you would draw your lines on the side, and then you would copy this ellipse back. Okay, so that ellipse would go there. It has the center axis running down through it. It has a vertical center line, and it has a center line running like that. Okay, if you needed a counterbore shape, you would draw one ellipse that looks like that, with give it a little bit of depth. And right at the center of where this ellipse would be, you would imagine there's a smaller ellipse there. I'll just go in and add that. Like I said, it'd be at the bottom of this guy. I'd draw a smaller ellipse and come down from the sides, and come down from where the sides of that would be, and add this ellipse down here at the bottom. And so there is a counterbore. And here's my center axis running down through the middle of that. Okay. Now, I know some of you guys are interested in architecture, and so I'm going to make a couple of architectural sketches here, and I've saved enough room for the architects in here, so don't worry about that. So first thing I want to show you is how do we handle inclined planes in an isometric drawing. So let's imagine that you have a front view of an object, and the front view looks like this, and the side view of that object looks like this right here. All right, so if I had to draw that isometrically, I would label it first. I would label this bottom edge as A, and this side edge over here is B, and this is C, and this side over here as D. And this plane right here is an inclined plane. And so even if I know what the angle is of this guy right here, let's say I know that that angle is whatever, 37 degrees, it won't measure 37 degrees in an isometric view. It's going to be skewed, okay? So here's how I would make an isometric of this drawing. I'm going to also label this width right here as E, and we'll call this inclined plane I right there. Here's how I would start. I would start at this corner, and I would identify that corner, and then I would take length A back at 30 degrees, and then I would take length E across at 30 degrees like that, and then I would come up D, and I would also come up D over here. So this is D, and this is E, and I would connect those, and this length I have right here is A. So where the end of A is, I have height B coming up. So I would go straight up, height B, and then I would take C, and I would come at a 30-degree angle. So this is C right here, and I would come across distance E, and I would connect those guys like that. And then I know that C and D are connected, and so planes, so this here is going to come across, and this is going to come across, and what I have is my inclined plane. And you can see the difference in the angle here and the angle here. They are not the same, and so the way that you determine what inclined planes are going to look like, you'll probably have to have an orthographic or a multi-view of this object before you can calculate where the endpoints of these guys are, and then you can add, you can connect the dots to get your inclined plane, which we have right here, right? Okay, now I said I was going to do something for the architectural types, and this is partly for them. And so what I want to get at is, what if you were just sketch a house, front view of a house real quick. Let's say that this is the front view of a house, and you're sketching for a client, and you're trying to show them this house that you're going to design for them. Okay, so there it is, pretty simple. And what I would do is I would label these links here. I called this C. This we could call D, E, F. And so if I have that, and then if I have a side view of that house, let's say that I know how long it is, so here's my side view of it. So I'll need to know what that distance is right there. Okay, so I'm going to come in here, I'm going to sketch that. So the first thing I'm going to do is locate a corner, like that corner right there. I'm going to go distance A at 30 degrees. Then I'm going to call this distance right here G. And so I would take G back at 30 degrees. And then I would add B, which is going to be a vertical line, would be that guy right there. And I would add F, right, that distance right there. And then what I would do is I would go to the center of this, and I would measure this distance from here to here, straight up to the peak of that roof right there. And I would come in here and I would transfer that in, and I would locate that point. And what I would do then, from that point, I would bring down the side of my roof, and I would bring this one down through F, which is this point over there. And then I would bring this back at 30 degrees, and I would bring this back at 30 degrees. I would use the same distance that it was in the side view. And so you can see I'm starting to get an isometric drawing created. We'll erase that guy out right there. Now, how do I handle the front door? Well, I measure over that distance right there, measure over that distance here, measure over from the side to the front door, and then go straight up the height of the door, which would be about 80 inches on a normal door, across at 30 degrees, and then drop straight down. Now, I also added in a roof vent, an attic vent right here, and it's round, and it has these louvers on it like that. That's what you would be seeing right here. So now I'm going to add that. I know it's going to be an ellipse, and if I look at my three planes here, which plane is it going to be on? Well, this is a right vertical plane that I have right here. It's pointing back to the right. It's up and down. So my ellipse needs to run at 60 degrees, its major axis. And so it's going to be sitting right up in here, running at 60 degrees. But these lines that you have right here are going to run at 30 degrees because they're parallel to A right here. So you're going to draw them at 30. So even though you drew your ellipse at 60, and there you go. So even if you're doing architectural work, being able to sketch quickly, isometrically, is really a good skill to have. Okay, and so it complements everything that we've been learning about, about doing front view and side view and top view. Our 45 degree in there. All right, because if you can take this line here and this line here and figure out what that distance is and what this distance is from looking at these views, and then you can take this height right here and put that in there, this length here, so you can relate. So really everything that you have drawn as a front, top, side view would be actually pretty easy to draw isometrically once you get the hang of it. Okay, so if anybody has a question about that, feel free to unmute yourself. And but what I'm going to do next is I'm going to switch over to AutoCAD. I'm going to show you how to translate this into making AutoCAD drawings. All right, so let me do this, and let me get rid of this guy. Okay, so on your monitor there, you can see an example of an isometric drawing done in AutoCAD. And so this line here and this line here, those are at 30 degrees. These are vertical right here, and these are those ellipses that I was showing you that run at 60 degrees on their major axis. Then you have this weird inclined plane. This is actually your first assignment, and I want to point it out to you in the book. If you look in the book on page 330, all right, so if you look at 330, you'll see that this is project 7.1. It's called the T connector. Kind of looks like a T, and it has some holes. You could probably run some screws or bolts through or something and tie some things together. Not sure why there's this 37-degree angle in there, but if you look at the sketch at the top of the page, you can see all the dimensions that you would need to draw this. Okay. Now, in Blackboard, there's also a video showing you how to draw this. So you can either follow the directions in the book and try to draw it that way, or you can play the video. And probably watching the video is not a bad idea, because there'll be more explanation as you go through watching the video of why you're doing what you're doing with AutoCAD. But you can see that in step 1 it says to download the Imperial prototype. The Imperial prototype is in Blackboard already. So if you open the chapter 7 for Blackboard, you can directly open the Imperial prototype and do a save as and name it T connector. Okay, and put that in your home folder. And then it says activate model space, which I'm in model space right now. And then it says in step 1, number D or D down there says set the units to decimal. So you'll want to do that. And then look at E and F. It shows you a couple of icons. Now, if you have an older book, you won't see those icons probably. But let me show you where those icons are located. They're really important. Right down here on your status bar, let me see if I can move this out of the way. Right along here on your status bar, you see this button you have right here? This is called ISO Draft. You have to turn this on. And if I turn it off, watch what happens. I'm going to uncheck it. Now look at my cursor. You see how it's just an X and Y cursor? But when I click on ISO Draft, look what my cursor does. It goes at 30 degrees and it's going vertically. That means that anything I draw right now that's ortho, with ortho on, would go at 30 degrees. Now, I'm going to press F5 on my keyboard and watch what happens when I press F5. You see how it switched it around? So right now it's set to ISO left. It means I can draw up and to the left, or I can draw straight up and down. I'm going to press F5 again. This is ISO top. Okay, so none of the ellipses that you see here would be drawn with the ISO top on. All of these ellipses, including these ellipses out here that you're going to be trimming and stuff, those are actually ellipses that are trimmed, are drawn on a right vertical plane. And so when you draw those, you would press F5 until it looks like this right here. Okay, that's how AutoCAD knows how to orient your ellipses. It knows to orient them at 60 degrees. It just doesn't know what plane you're drawing them on. And so you have to tell AutoCAD, okay, I want to draw ellipses on the right vertical plane, and so you've got to be toggled to the ISO right. Again, here's ISO left. You can see these ellipses don't line up with ISO left. And then that's ISO top. Now, on your next assignment, you will do some isotops and stuff, so you'll get some practice at that. Okay, so I've got that set to ISO right. So I want to show you how to put in an ellipse. I'm going to go over here to my draw toolbar, and there is an ellipse command right here. Okay, and you also have an ellipse command up here. Okay, so I'm going to pick on the ellipse, and there's an important step you have to do after you pick on the ellipse, and that is this. AutoCAD doesn't know you want to draw an isometric ellipse yet. So look right here on your command bar. You have arc, center, and you have ISO circle. AutoCAD calls an isometric ellipse an ISO circle. There's another one of those stupid made-up words that they've put in here. Like they couldn't call it an ISO ellipse. It's got to be an ISO circle. Well, it's not a circle, dude. So anyway, you pick on ISO circle. All right. You move it around, and it says specify the center for the ISO circle. So let's say that you've located where that point is right there, and it's out here. I'm just going to pick. All right. Now look down here on your command line. It's defaulting to a radius. If you know the diameter, though, you can just come right here and pick on the word diameter, and then you could type 2 and press enter, and it would draw a 2-inch diameter like that. Okay. Now I'm going to just quickly draw something. So I'm going to pick on my line command, and here's the deal. I want to make sure that ortho is on. Now remember, ortho just lets you draw straight lines left and right and up and down, unlike polar, which lets you go at angular increments, right? I'm going to pick on ortho mode here. I think ortho's probably the better tool to use when you're doing an isometric. And remember, you can turn ortho on and off with F8. So you're going to be using F5 and F8. So it says specify the first point. I'm going to pick right there, and see what it does with ortho on. I can move in that direction. I can move in that direction, but those lines are at 30 degrees. The other way it will let me move is straight up and down, but I'm restricted to 30, 30, straight up and straight down. So I'm going to go in this direction. I'm going to type 3 and press enter. Then I'm going to move straight up and type 3 and press enter. And then I'm going to move in this direction and type 3 and press enter. And then I'm going to come back to my start point and pick and press escape. So there's a vertical plane right there drawn in as an isometric. Now I'm going to press F5 and change to the ISO left axis. I'm going to pick on the line command. I'm going to pick right here, go in that direction, type 3. I'm going to come straight down, type 3 and press enter. I'm going to come to right there. And then what I could do, I could use copy. If you pick on that line and then you press enter, and it says specify a base point, you could pick at that corner, that end point right there, and just copy it right there, press escape. You could press enter, it will bring you back to copy, pick this guy and press enter, and pick right here. And look, I'm trying to move up there, but AutoCAD doesn't want to go that way. I need to press F5, and then I can move to there and pick. All right, so now I'm going to draw a line from corner to corner, because what I've drawn is a 3-inch cube. It's 3 inches on all the sides, and I'm going to draw a corner from here to here, and draw a corner from here to here, from this corner to this corner. Now I'm going to go back to my ellipse command. I'm going to pick on ellipse, and I'm going to choose ISO circle, and look at how my ellipse is oriented. That is for an ISO top. So this would be an ISO top. So I'm going to snap to the midpoint of that line right there. I'm going to pick on diameter, and I'm going to type 2 and press enter. All right. Now I want to draw an ellipse on this right vertical plane, so I would press F5. See how it oriented that? Come back to my ellipse, pick ISO circle. If you don't pick ISO circle, it's not going to work right. And then I pick at that midpoint, pick diameter, type 2 and enter. And then the final circle I'll draw, or ellipse I'll draw, is that guy. And I pick ISO circle and I snap right there. Something didn't work right. Let's try it again. Pick right there, choose ISO circle, and I pick at my midpoint. Now look at that ellipse. Does that look correct? It doesn't. See, it's not oriented. Your brain's like going, wait, that's not the way that would run. So even while you're in the command, if you press F5, you can orient it. Now that looks right there. So then now remember, whenever you have a word on the command line and it's capitalized, all you have to do is type the capitalized letter. So if I type D and press enter instead of picking on the word diameter, it puts me into the diameter option. I could type 2 and press enter. Then I could come in here and just delete these guys out. All right. So that's how, you'll kind of get a workflow thing going of knowing that you're going to be pressing F8 and toggling ortho on and off. Generally, it's going to be on. And then you're going to be pressing F5 to rotate your ISO plane. And then remember, use ellipse, ISO circle when you draw the circles. So here's the way this project works. I'm not going to draw it, but I'm going to show you that in step 3, it shows you to draw a vertical line that's 3 inches long and to draw a horizontal line that's 5 inches long. Okay, so from this point right here, you would draw 2.5, and from here you would draw 2.5, and you would have ortho on, and your ISO right would be set, that guy right there. All right. Once you have that, if you look at step 4, it says to use the following steps. Then 4, concentric circles. Draw 2 concentric circles at each of the 3 endpoints. Draw a 1-inch diameter ISO circle and draw a 2-inch diameter ISO circle. So this is a 1-inch diameter ISO circle. It would match this guy right there, except this is 2. And then this is a 2-inch diameter ISO circle, and they're drawn right at the end of that line right there. You would do that again at the end of this line and the end of this line. Now, what the ninja would do is they would not draw those. They would pick these guys and they would go to copy. And when it says, where's your base point, they would pick at that endpoint right there, and then they would pick at that endpoint, and they would pick at that endpoint, copy those guys. But you probably need the practice anyway drawing ellipses, so if you draw those ellipses, it won't hurt you. Now, here's the thing. Now we need to draw lines that are tangent to the tops of those ellipses. And if you go in here with your line command and you go over here to this ellipse, you can see it's hopping around. It's kind of confused because that's an ellipse. It's not finding the quadrant. And when you go over here, it's looking for a tangency, which is good probably, but we need something from the quadrant right here. So what you have to do actually is draw a construction line from the center here just straight up like that. Then you can pick on it and stretch it down. This construction line right here allows you, if you get in the line command, to find that intersection and then go tangent like that, and then do the line from your intersection tangent here. And so I would do the same thing. I would draw a line across here from my center point like that, and I've got ortho on. That's why I know it's going exactly 30 degrees. And now I can find a line from that intersection and draw it up, and draw a line from this intersection and draw it up like that. And so what's going to happen eventually is you will have this constructed here, and then you'll go in and you'll trim all this stuff out, and you'll get it to where it looks like this guy right here. All right. Now, once you have this guy drawn, what you'll do is, and the video will show you how to do this. I'm going to press F5. You're going to copy everything on this front edge that you've constructed. Let me just grab a bunch of that. I don't know if I've got it all or not. And then you would copy, and you would pick a point, and you would move back like that 1 inch, but I'm going to go 3 just to show you how far back it will go. You see, I can copy that back, and then all I have to do is draw lines that connect it. That's how you get the thickness of this guy. Let me undo. The way you get the thickness is once you have the front part drawn, copy it back 1 inch, connect the lines from one plane to the next, and then trim everything in the background to get the T connector to look like that. All right. So that is the first assignment. You would go into your layout tab and you would print it as a PDF. It'll be T-connector. And remember, you can't edit this text if you're in model space. You've got to pick on that, and then you can come in here and you can edit this stuff. So you'll have your T-connector, and you can email that to me. All right. Now, I want you to turn to page 334 in your hymnal. And look at the top of the page, and you'll see your old buddy, the tool holder. And you've already drawn this, and you've put dimensions on it. At least most of you have. And so what you're going to do now is you're going to go in and you're going to open up the drawing that you made last week, which will have the front, the top, and the right side view of the tool holder with dimensions. Okay, and it'll have this note. So you're just reopening the tool holder, but you're going to add this guy. You're going to add that isometric view of it. And so if you look on page 334, it gives you the steps, and it even shows you step by step how to construct it. And by the time you get to the bottom of page 336, hopefully you'll have your view. Now, what I think is important, if you look at the bottom of page 334, you can see what's called a bounding box. A good way for beginners to start is to look at their parts and say, okay, well, this thing is 7 inches long, and it's 2.5 inches wide, and it's 2.75 tall. So before you try to draw your isometric, you draw a line right here that's 2.5, and you draw a line straight up that's 2.75, and you draw a line in this direction that's 7. And then you could copy these lines. And so what you're doing is you're creating what's called a bounding box. And your part will fit inside that bounding box. And it actually helps you to draw it because you've got it there. The approach is like, remember Michelangelo, the artist, he was a great sculptor. And he always said that he would just get a block of marble, and that what he wanted to carve was already in the marble. He just had to knock away the edges and all the stuff. That's kind of the approach here. The bounding box represents your piece of marble, and you're going to trim away at it. You're going to construct and trim, and and eventually you'll be left with this piece right here. Okay. And so the reason I think that having the bounding box is important is, let's say you're trying to figure out where that line is right there. Well, we know that that line is 0.75. That's 0.75 from here to there. Okay? So if I were constructing that, what I would do is use the copy command, and I would pick that line right there and press enter, and then it says select a base point. I would actually pick out here in space, and I would make sure that ortho is on, which is F8, and I would move in this direction, and I would type 0.75 and press enter. All right, so you see how by copying this line over 0.75, that gives me the edge of that cutout. And that cutout, I know, goes back in 1.5 inches. So what I would do next is I would do a copy, and I would pick this line and press enter. And instead of picking right here on the edge, I would just pick out here in space somewhere, and I have ortho on, and I would just move in that direction right there and type 1.5 and press enter. And so there's the back edge, and so now I could come in here and do a trim, and I can start trimming this guy out and finding where that slot is. Like this slot right here, it's 1 inch. I would do a copy, and I would pick on this guy, and I would move straight down. The reason why I was picking out in space is this. Let me show you. Do a copy. If I pick right there and enter, and it says pick a base point, if I pick right there and I try to move down, it might jump down there and grab the midpoint. Okay, so I know that if I do a copy and I pick on this and I enter, but I pick out here in space for my base point, when I move down, it's not going to jump to a midpoint or an endpoint or anything like that. So I just move in that direction and type 1 and press enter, and it moves right down there. And so you can see these ellipses. These are isotop ellipses. This guy right here is actually an isotop ellipse that has been trimmed. Okay, so the thing I want to show you about, and then I'll cut you loose, I'll show you where this is in Blackboard. You would think you would use the fillet command on this, but AutoCAD has never made fillet work right in an isometric drawing. So if you use fillet, so you go right here, and you know your radius, you pick on radius and you type 0.5 and press enter, and then you even press F5 to get in the right. If you pick here and then you pick there, look at the difference between the fillet and what it looks like on what I had drawn earlier using an ellipse. Okay. The reason why it doesn't work is that the fillet command draws round fillets, not elliptical fillets. That's why your drawings won't look right if you use the fillet command. So instead, what you have to do is use the ellipse, iso circle, and you have to draw it like that. Okay, using ellipse iso circle, and then you'll get an elliptical ellipse like that right there. And then you'll go in and do a trim and go in here and trim all that stuff out, you know, to get to your, and then eventually you'll start trimming these corners out and stuff, and then you'll have your front corner. Then I would take that ellipse and copy it straight down 1 inch to get it to right there. Instead of trimming that, though, you just copy it. Okay, so the next thing I'm going to do is show you, let me drag this over. I'm going to show you Blackboard. So you're going to log into Blackboard, and then you're going to click on Chapter 7. When you click on Chapter 7, there's Assignment 1, which is Project 7.1, and Assignment 2. You click on that guy, and it tells you, here's your prototype, right here, Imperial Prototype. And then it says, watch this video, creating an isometric drawing of the T-connector. So you can click on that and watch that as you create the video, and then you'll print it and send it to me. Then you'll go back to here, and you'll click on creating an isometric drawing of the tool holder, and it says to open the tool holder project, and then here is a video that you can watch on doing that if you want to watch that, and then you'll print that, send it to me, and together these will be what we'll do in Chapter 7, these 2 assignments. And so I would like to have these done before next Tuesday at 11 o'clock. And they go pretty fast, and they're kind of fun, actually. So let's see if I go back here. I'm going to add something else. Let me see. You see this folder right here, optional extra credit? If you click on that, it's got some extra credit projects for Chapter 7, and there's a PDF. I'm going to click on that, and let's see if I can open it up so you can see what it looks like. So what you could do is open up the bracket project where you drew the front, top, and side and put dimensions on it. And if you want to draw the isometric of it, here's a help sheet for drawing the isometric. You could add that to the upper right corner of the bracket project. You could do the same for the shaft guide project if you want. And then you could create an isometric of the tool slide if you want. Now, you're not required to do these. These are all extra credit. And here's how I do extra credit for this class. If you draw this correctly on the bracket project and you submit it to me, I will put a +1 in my grade book, and whenever I calculate your final grade for the course, your final average, I'll add a point to it. Okay, and so if you do this one and the other one, I'll add another point, and if you do this one, I'll add another point. So, you know, let's say that you've got an 87 average at the end well, I'll add 3 points to that and you might make an A in the course. Okay, so you don't have to do these, but they're available for you to do if you want. Okay. Let me show you another opportunity for an extra credit on this one. Right here. Okay, so you're going to draw the tool holder where it will look like this. This will be the orientation. If you were to also draw it where it looks like this, because there's no directions and there's no video for this. So if you draw it backward, in addition to the other way, I'll give you an extra point for doing that as well. Okay, so that's the assignment for between now and next Tuesday. On Tuesday, we'll start a new assignment. So you just need to get the T connector done and get this guy done, and you're done. And then you can do the extra credits if you want to. That's up to you. Okay, so does the offset command, yeah, the offset command does not work correctly. It's going to give you, yeah, okay, so you're asking even on lines probably, is that what you were getting at? Yeah, you can't use the, yeah, the offset command doesn't work correctly either. You've got to copy, okay? Because if you do an offset, so let me go to offset, and let's put a 0.5 offset in, press enter, and I pick on this guy right here and pick. What it does is when it offsets it, it offsets it parallel, so it kind of goes straight up. It doesn't, let me show you the difference between copying something 0.5. If I pick right there and enter and pick, and I move in this direction and I go 0.5, you see where it hits at a different place than if I offset it. So don't use offset and don't use fillet.